A different type of example using very similar techniques is finding the distance between two lines. I'm going to give two examples here. The first one's pretty straightforward. And imagine I had these two lines here, x equals 5 and x equals negative 11. Well, if I graph these ones here, just to show you, if I showed you this one here, x equals 5 would be 1, 2, 3, 4, 5. It's actually a vertical line that looks something like this. There's x equals 5. X equals negative 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would also be a vertical line right here. So here's x equals negative 11, here's x equals 5. Okay, x equals 5, and here's x equals negative 11. Well, this one's very straightforward because I don't have to do much math. I just want to find the distance between, let's say, these two lines. Well, because they're vertical, it's just going to be the difference in increments between them. In which case, I'm going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, or I could have just found the difference between 5 and negative 11 is 16. So in fact, the distance between these two lines will equal 16, and you're done. The same thing would happen if I had horizontal lines. You can only find the difference between them, and it makes it a little easier. A more challenging problem would be something like this. In other words, I had two lines that weren't horizontal or were not vertical, and that would be something like y is equal to 1/3 x minus 3 and y is equal to 1/3 x plus 2. You'll notice these lines are parallel because they have the same slope, 1/3. So these are going to be parallel lines. Now I'm going to call this line 1 and this one line 2 just to illustrate a point here. Let me sketch this real quickly for you. Just a very brief, quick sketch. This one goes through the point, okay, so there's negative 3, and it's going to have a slope of 1/3. Okay, and so it's going to be positive 1/3 of some sort. So it may look something like this. Again, this is just my quick sketch. The other one goes through 2, and it has a similar slope. So right now, here are what my two lines would look like. Here's line 2, there's line 1, according to my diagram. Very quick sketch. If I want to find the distance between them, it will be like a distance like this. Okay, it has to be 90 degrees to both. You can't draw it like this. So that's why the difference won't be 5 here, because that would be going vertical, which is not the distance, it's the shortest line. Now, to do this, I'm going to choose one equation. I'm going to choose this first one here. And what I'm going to get from that first one is I need the equation of the line that's going to be perpendicular. And I'm going to choose it right from here, where it was negative 3, and say, what if I chose that point, okay, which actually is the point, if you look at this, it'll be the point 0, comma, negative 3. That will be the intercept, because it equals mx plus b. Knowing that, I want to find this line. That'll be 90 degrees to that other one, okay, to line 2. I want to find out what its equation will be. I'll call that line 3. Okay. At this point, okay, I need to find out what this equation is, but it's actually really easy. What's the equation of line 3? Well, it's going to be y is equal to, well, because it's perpendicular, the negative reciprocal of that line, which will be negative 3 x, and it turns out it has to have the same intercept because we defined it as going through this point. So I can just write minus 3. Here's the equation for line 3. And in fact, at this point, I no longer need 1. In fact, this one is no longer of use for me. I'm already done with it. I'm going to put a little check mark saying I'm already done with that line. Now I have to focus on this line because I need the intersection between 3 and 2. How do I get that? The exact same way we did before. We are going to set this equation equal to the second one. Again, the first one you're done. We've already dealt with it. I want to find this intersection. And so to do that, I'm going to get here negative 3x minus 3, this equation. This will be equal to this one, which in our case is 1/3 x plus 2. Now, you may notice there's a 3 in the denominator. I don't like that, so I'm going to multiply everything by 3, in which case I'm going to get negative 9x minus 9. This will be equal to x plus 6. Okay, this will be equal to x plus 6. Now, when I punch this in here, I'm going to move this around here, and I'm going to get 10x, if I move this to one side, I get 10x, and here I'm going to get negative 15, in which case x will equal negative 1.5. Again, plugging negative 1.5 back into, let's say, this equation right here, I'm going to get y is equal to 3 times negative 1.5 minus 3. 3 times negative 1.5 minus 3. That should give me, let's see, 3 times negative 1.5 will give me negative 4.5 minus 3. Sorry, this should be a negative 3. So in fact, you'll get plus 4.5. I just realized that was a negative 3. And so you'll get plus 4.5 minus 3, which will give you 1.5. In other words, this intersection right here is the point. This is my y, here's my x. So this will be the point negative 1.5, comma 1.5. So negative 1.5, comma 1.5. Now I have to find the distance between these 2 points. And when I do that, just to show you, the distance formula will be x2 minus x1 squared plus y2 minus y1 squared. And plugging in my points, I'm going to get negative 1.5 minus 0. And so that should be, well, that's just going to be negative 1.5 minus 0 squared plus negative 3 minus 1.5. Negative 3 minus 1.5 squared. And I'll let you do the rest of this one here. You're ultimately going to get here that this will be negative 1.5 squared